Hi everybody, welcome to the second part of section 2.3 where we will talk about solving equations of the form ax equals c. Some number times our independent variable x equals to c, and we would need to figure out what x is. So what are we going to do today? I sound like Phineas and Ferb. Well, we're going to solve equations of this particular form. And what else are we going to do today? We are going to do an application. I know you guys are stoked about applications, as am I. In our last video, we talked about the addition property of equality. Here we're going to talk about the multiplication property of equality or the division property of equality. They're pretty much the exact same thing. And let's just start off with this. Okay, we know that this statement is true. 3 plus 7 does indeed equal 10. Well, if we multiply both sides by 2, we get the we still have a true statement. 3 plus 7 times 2 is equal to 20, as is 2 times 10. Furthermore, if we divided both sides by 2, we have, yet again, a true statement. 3 plus 7, that quantity divided by 2 is 5, and 10 divided by 2 is 5. And once again, this kind of like this parallels with the idea that we talked about before, which is that the equality is preserved if we do the exact same thing to both sides of the equation. Here we multiply by 2, here we multiply by 2, it's still equal. Here we divide it by 2 or multiply it by 1/2, your choice. And we divide it by 2 or multiply it by 1/2, and the equation is still the same. And that is the idea of the division property of equality. The basic thing you need to understand, though, is whatever you do to one side of the equation, if you want to maintain the equality or if you want to have an equivalent equation, you got to do the exact same thing on the other side. Now, mathematically, how are we going to do this? Well, let's let A, B, and C be expressions. They can be numbers. They can be letters, they can be anything you want them to be. The only thing that requires is that C not be equal to 0, because if C is 0, then basically nothing happens. If the statement A equals B has a certain set of solutions, then the statement A times C equals B times C will have the exact same set of solutions. We will call them equivalent equations. Furthermore, the statement A divided by C equals to B divided by C will also have the exact same solutions. These these equations are considered to be equivalent because, once again, they're all the solution for one equation will be the same solution for the other two equations. And that is the basic idea behind the multiplication or division property of equality. Well, how can we use these? We can use these for an equation of this particular form. I know that's very difficult to see, but we can use the multiplicative property or the division property to get rid of that A and put that on the other side, namely isolating x. Because remember, when we want to find out what x is, you want to get x on the one side, all the other crap on the other side. And how are we going to do that? Well, we're going to have, once again, a three-step procedure. The first thing is that we are going to simplify our equation. It may not look like this, so we might need to combine like terms to get the equation to look like the form of A times x is equal to C. And once again, simplification will typically involve the idea of combining like terms. And what are like terms? Well, those are terms that have the exact same variable and the exact same exponent, or terms that have no variable at all. Okay, step 2 is to isolate x. And what we're going to do is we're going to use the multiplication principle of equality and multiply both sides of the equation by 1 over a. So if this is a, we are going to multiply that by the reciprocal of that, which of course would be 1 over a. Here, a happens to be 4. So we're going to multiply both sides by 1/4. And then of course we're going to simplify. 1/4 times 4 is equal to 1. 1/4 times 20 is equal to 5. So once we're done, we will have that x is equal to 20 divided by 4 or 5. And then the last thing to do is check. What we can do is we can take our 5, put it back into here, and see if the resultant statement is true. And lo and behold, it is, so we are good to go. And now it is time for examples. Okay, and here is our first example. Here we have 5x is equal to 30. And we want to figure out what x is. Well, remember, step 1 is to simplify. Not a problem. It's already simplified, so this is done. We have 5x is equal to 30. Now we want to multiply or isolate x, and we can do that by multiplying both sides of the equation by 1/5. So I'm going to multiply this side by 1/5, and I'm going to multiply this side by 1/5. Okay, well, isn't that convenient? What's 1/5 times 5? Hey, that's equal to 1. So all we have over here is 1 times x, or just simply 1. What is 1/5 times 30? 6. We have that x is equal to 6. So isolating x is done. Last thing we need to do is check. Well, checking here is pretty straightforward. We're going to take our 6, we're going to substitute it back into the x, and if we do, we will have 5 times 6, which is equal to 30. Hey, that's true. So we are good to go. Here's example number 2. Now notice this one, we have a whole bunch of terms. It's not in the form ax is equal to c. So we're going to have to do a little simplifying. That very first thing we need to do is simplify right here. And that involves combining like terms. Now remember, like terms are those terms that have the exact same variable and the exact same power. So this is an x to the first power. This is an x to the first power. So these two are like terms. Or they can have no variable at all, which these two are. And also like terms have to be on the exact same side of the equality. So we can combine 1.1 and 1.1x and 0.2x to 1.3x. And over here we can combine 12.2 minus 3.1 to 9.1. Okay, once we've done that, now we can isolate x. And how can we do that? Well, we can divide. We want to use the multiplication property of equality, or probably more accurately, the division property of equality, and divide both sides by 1.3 because we want to get this coefficient to 1. And we can do that by dividing both this side by 1.3. 1.3 divided by 1.3. So when we have x. Now remember, what you do on one side, you got to do on the other side. So let's divide this side also by 1.3. Okay? And then when we simplify, these cancel. We're just left with x. Over here, we have 9.1 divided by 1.3. Now, some of you might be able to realize that is equal to 7. If it's not, use your calculator. Hopefully, you will get 7. And there is our answer for x. Last thing we need to do is check. Well, that should be pretty straightforward. We can just take our x, substitute it back into here. And if we do, we will have 1.1 times x, which is 7.7, plus 0.2 times x, which is going to be 1.4, and that is equal to 9.1, which of course is also what 12.2 minus 3.1 is. And there you go. You're done. Now this one involves fractions, and yes, I know we all hate fractions, but nonetheless, you're going to need to deal with this in this course, and also a few courses along in your collegiate math career. Remember, the first thing we need to do is simplify. Well, in this case, we really don't have to, because in this particular case, a is 4/5, and there's our x. And c is 3/10. So we are actually good to go there. Now the next thing we need to do is to isolate x. And remember, we want to multiply this equation by the fraction that will make this equal to 1. And that is going to be the reciprocal of 4/5. And what is the reciprocal of 4/5? 5/4. So we want to multiply this by 5/4. Now remember, what we do on one side, you got to do on the other side. So we can also multiply this by 5/4. Okay, now here's the one place where fractions really aren't that bad. You know, when we add and subtract fractions, we have to find a common denominator. There's a little bit of work we have to do to make sure the denominators are the same. In this case, it's not that, and here multiplication is not that bad. For example, if we are going to multiply 5/4 by 4/5, we do this as follows. The new numerator is just the product of the numerators, which will be 20. The new denominator is going to be the product of the denominators, which is equal to 20, which, of course, 20 divided by 20, that's equal to 1. So we just have x down here. And we do this multiplication the exact same way. 3/10 times 5/4. Okay, well, 3 times 5, we just we multiply the numerators together. 3 times 5, that's 15. That's the numerator of the product. 10 times 4 is 40. So this is 15 over 40. Now here's where things get a little tricky. Now notice here, we need to look at this and we need to realize that this fraction is not reduced. Why is it not reduced? Because 15 and 40 have common factors. And we need to identify what those common factors are and factor them out. For example, 15 can be written as 3 times 5. And 40 can be written as 8 times 5. Okay? Which means that we have 3 divided by 8 times 5 divided by 5. I kind of just did multiplication reverse. What's 5 divided by 5? That's just 1. So this is actually equal to 3/8. So in this case, we have that x is equal to 3/10 times 5/4, which turns out to be equal to 3/8. And there you go. Last thing you need to do is then check to see if you're right. Now notice here we have 4/5, and we want to substitute the 3/8 back into x. So that's going to be 4/5 times 3/8. And to do this, we are going to multiply the numerators together. That's going to give me 12. We're going to multiply the denominators together. That is going to give me 40. Okay, now notice that this can be reduced. For example, 12 can be written as 3 times 4. 40 can be written as 10 times 4. This is 4 divided by 4, so this can actually, which is 1, so this would actually be equal to 3/10, which is what we were looking for, so we are good to go. Now, here is our next equation. Now, you might look at this and say, hey, man, I'm done. It's just negative x. Well, remember, negative x is still an a. As a matter of fact, negative x implies that a is equal to negative 1. I can actually rewrite this as negative 1 times x, like what we have here, is equal to 4. So no, we are not done, but getting there is actually pretty straightforward. Matter of fact, a lot of you can look at that and go, hey, yeah, man, x is negative 4. And if you can, more power to you. I'm going to walk through it. The exact same approach that we did. First thing we need to do is simplify. Well, we really don't have to, except maybe to make this a little more explicit. This is pretty much fine the way it is. But I'm going to write it in the explicit fraction. Actually, I'll do it both ways. So here we have negative x is equal to 4, which is just like negative 1 times x is equal to 4. Okay, now once again, we need to isolate x. Notice that x is not isolated. That minus sign is still there, so it is not by itself. So we want to multiply this by something that will make this go away, and that will be negative 1. Why? Because, well, negative 1 times negative 1 is, well, you guessed it, 1. All right? And I'm going to multiply this side by negative 1. I need to multiply the other side by negative 1. Okay, I'm going to put parentheses around here just to show that we're multiplying here. All right, so once again, here we have negative 1 times negative 1. That's just positive 1, and we're just left with x. And over here we have negative 4. Once again, negative 1 times negative x is just simply x. And then over here we have negative 4. So in both cases, the explicit one and the more straightforward one, we have that x is equal to negative 4. Checking it? Sure, let's go ahead and do that. X is negative 4. So negative, making the substitutions, negative of negative 4 Well, that is just equal to 4, which is what we were looking for. Okay, and that is all of the examples that we wanted to talk about relative to this. The next thing we want to talk about is an application. And this is the kind of application that you might see on your homework. Here we have the original price of a Blu-ray player was reduced by $45.50. And so you got to buy it for $165.90. Do any of you guys know what a Blu-ray player is anymore? They were big when I was about your age, but I don't think anybody uses them anymore, thanks to iPads and streaming and whatnot. But they are still around. Actually, my house is so pathetic, we still have a VCR player. Okay, so we want to determine the original price of the Blu-ray player by solving this equation. This is the equation that we need to solve. Y minus 45.50 is equal to 165.90. Now what you'll notice is that this is really more of a section 2.3a problem than it is the stuff that we have to do that we're talking about today. But nonetheless, we have the tools to solve this. We want to solve for y. And the first thing that we want to do is get it into the form of x plus b is equal to c. Well, it's already there. Done. So we've already simplified. Okay, there it is. I know you can't see this anymore, but it's right down here. Next thing we want to do is we want to isolate y. And here now, since we actually have an addition problem here, we want to use the addition property of the equality. So I'm going to add 45.5 to both sides of the equation. I'm going to add 45.5 here. Whoa. There we go. And I'm going to add 45.50 here. And I'm going to go ahead and add this vertically. These, of course, cancel. All I have over here is y. And then y is going to be equal to 0, 4, point, got to carry the 1, 1, carry the 1 again, 1, carry the other 1, 211.40. Okay, and let's go, that's what y is. And now to check, what we're going to do is we can take this, put it back into y, and see what we get. Well, that's going to give us $211.40 minus 45.50. And what's that going to be equal to? Let me see. 211.40, 45.50. All right, well, that's just 0. Here I got to carry. 14 minus 5 is 9. Borrow and carry. 10 minus 5 is 5. Borrow and carry. 10 minus 4 is 6. And then we have the 1. So this actually turns out to being 165.9. And there you go. And that is everything that I wanted to cover in this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.